What up, pals? Let's move. Let's move. More geometry. We're going to start a whole new unit today on polygons. So there's a lot of stuff we're going to cover in the unit. But finally, we're going to get to more than triangles. Yay! And now, when it comes to shapes and all that stuff, we're going to start dealing with a lot of things. But we begin the whole unit on an entire lesson about angle sum theorems. But first, an overview. What's going to happen in this entire unit is we're going to get comfortable with all sorts of polygons. Look at all these polygons. And mostly in the unit on polygons, we're dealing with quadrilaterals. And so there's all sorts of stuff with quadrilaterals, but we'll get there because the first lesson is about angle sum theorems, and that means we're going to play with things that aren't necessarily quadrilaterals. We're going to play with all sorts of neat shapes. So in the first lesson, we're going to find angle sums. We're going to talk about angle measures. We're going to talk about exterior angles, a lot of neat stuff. And we'll start this whole thing off with some notes. You know how it goes. So a couple of notes, because we're dealing with, like I said, we're dealing with polygons, not necessarily quadrilaterals. We will get there, but just with any polygons. So we have a couple of things to work with notes. This is a good time to pause and copy and all that stuff. But let's talk about angle sum theorems. So we have the angle sum of interior measures of an n-gon. What's an n-gon? A polygon with n amount of sides. So what this means, n-gon, like a quadrilateral has 4 sides. It's a 4-gon. So the sum of the interior measures is the number of sides minus 2 times 180. And we're doing an activity in class that you're the one that really discovers that in your own. But we do that in class. So if I don't teach you in my class, well then here's the note. And then we have the corollary to that. The measure of each interior angle happens to be of a regular n-gon. And here comes this neat word, because it's a sneaky word. Regular, same size, sides, and angles. Nah. So that's what regular means, a sneaky word. So we learned about that. The measure of each interior angle, a regular n-gon, is the total amount of interior angle degrees, but then divided by the number of sides. And it has to be regular because that means the sides are the same side. And then we go back to exterior angles. Oh, yeah. You remember exterior angles? I hope you do. So we talk about an exterior angle. What's an exterior angle? When you extend the side of a polygon, you have an exterior angle. You guys remember that? When you extend the side of a polygon, you have an exterior angle. And so look what happens with polygons. You can have multiple exterior angles. So the cool thing is the sum of the measures of the exterior angles of any polygon, no matter what, one in each vertex, the sum of the exterior angles is 360. Isn't that cool? So in this case, for the pentagon, all of these exterior angles, angle 1, angle 2, when you add them together, you're going to get 360 degrees. So I have 2 random pentagons here. Why would I do that? Well, if you look at this picture, what's happening? We're extending the sides of the polygon in this direction. Do we have to extend the sides of the polygon in that direction? No, we don't. So in this first pentagon that I have, I'll extend it in the other direction. And so we have angle 1 there, an exterior angle 2, an exterior angle 3, an exterior angle 4, an exterior angle 5. That's still, the sum is going to be 360. So here's the exterior angles. That sum is going to be 360. So what's the deal with this other pentagon? This is my how not to pentagon. What is not an exterior angle is this. Okay, so if you extend the side in both, this is not an exterior angle. So you can't do that. Burp, burp. That's my how not to pentagon. So the exterior angles just extend one side in one direction, then you have exterior angles. And it doesn't matter which direction you go. It's still going to be exterior angle. And the sum of all those exterior angles is still going to be 360. So here's a neat little cheat sheet. This is what we're covering in class, actually. And the cheat sheet is a list of all the different, not all of them, but at least down to 10, from triangle, which is, by the way, a neat trivia question. What is the smallest polygon possible? A triangle. Anyway, that's a neat trivia question. So we go from triangle all the way down to decagon, and we figure out the number of sides each has, and this is what's important, you got to know the vocabulary: triangle 3, quad 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So we have to know those sides, and we're going to do this in class. Number of triangles formed gives you that. The interior angle, this is that theorem we were talking about with an n-gon, right? An octagon, for example, has 8 sides. That's an 8-gon. So the interior angles is going to be 8 minus 2, 6 times 180, or 1080. Okay? Then we have the sum of the exterior angles, 360. If it was a regular polygon, then each interior angle measure would be divided by the number of sides, and then the exterior angle measure, 360, divided by the number of sides. So a neat cheat sheet. If any of this was confusing or I talked too fast, this is a pause and rewind moment. This is pretty huge. You can make your own. If you're not in my class, I would seriously say make your own. So these are the notes, right? And we're going to start digging into those notes with some examples. So if you didn't understand stuff, well, buckle up. Maybe you'll pick it up along the way. You know, it's possible. So now we're going to talk about how do we find angle sums. Well, let's use these notes we were talking about. Here's a question. What is the sum of the interior angle measures of a heptagon? So if you remember, what is heptagon? 7 sides. Okay? And how do we find interior angle measures? Well, remember the note. The sum of the interior angle measures of an n-gon, n minus 2, times 180. So in this case, we're looking at 7 minus 2 times 180. Right? So this is how we would use that. 7 minus 2 times 180, or 5 times 180, which you can use a calculator or you can do the thing. It doesn't matter. I have a calculator in front of me, so I'm using it. Either way, you're going to get 900. So it's going to be 900 degrees is the sum of the interior angle measures of the heptagon. And that's how this theorem works, folks. That is it. It is that straightforward. And you can see, too, from that cheat sheet, we just talked about a heptagon, right? So a 7-sided figure. The sum of the interior angle measures is 900. Okay, so we can use, we can either derive that cheat sheet or we can use it. Doesn't matter, but that's how it works. So next question, what's the sum of the interior angle measures of a 17-gon? I don't know offhand what a 17-gon is. It'd be kind of cool if I looked it up before the video, but whatever. You look it up. Google it. I don't care. So how do we figure it out? Well, 17 minus 2 times 180. That's how we figure it out, right? So remember, the formula that we will derive in class happens there, so we just use it. Okay, so 17 minus 2 is 15. So 15 times 180, that big number, whatever it turns out to be, 2,700. So that's our sum of the interior angles. It's that simple, pretty straightforward. Okay, so that's how the angle sum theorem works for these examples. So now, to capture the imagination of all of our future biologists and horticulturalists and fly people, here's this question. So, in biology, the common housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Now, facet is like a space. It's a spot, right? So a facet, it's like a space. Each facet is a regular hexagon. There's that word regular. Regular hexagon. What is the measure of each interior angle in one hexagonal facet? So you got to remember, regular. What does regular mean? Regular means that each angle in each side has the same measure. Okay, so that's how we can approach this. Now we're looking for each interior angle. Well, what's going to be the total angle sum of a hexagon? Now, first of all, we got to know a hexagon means it has 6 sides. Okay, so we have to find the total interior angle measure, right? So the sum of the interior angles is going to be 6 minus 2 times 180, or 4 times 180. Remember, we just used that fact previously. So what is that? 360 and 360, 720. Okay, so we're going to get 720 degrees. So the sum, the total of the interior angles is 720 degrees. So we just use this note, right? But now the question is, what's the measure of each interior angle? Well, that was that second note. The measure of each interior angle of a regular n-gon is the total, the sum, divided by the number of sides. And so we have to take this 720 degrees and then divide it by the number of sides. Now in a hexagon we have 6 sides, right? So simply we divide it by 6 and we get 120. So the measure of each interior angle in one hexagonal facet is 120 degrees. Okay, so that's how that question works. We're just using those notes. That might seem confusing at first, but when you get practice, or if you do the activity in my classroom, it should make a whole lot more sense. But more importantly, you got to know your vocab. Please remember what regular means. Each angle on each side has the same measure. Okay, so that's how that works. So let's see if we can get some more practice, right? So here's the next question. Why don't you pause it and try working it out yourself? What's the measure of each interior angle in a regular nonagon? Well, what is a nonagon? Nonagons have 9 sides. So if we're going to find the measure of one of the interior angles of a nonagon, we've got to find the total, right? What is the sum? Right? What's the entire interior angle sum? And so we have a 9-sided figure minus 2 times 180, okay, or 7 times 180. And so we have that big number. As I punch it in, 1260. So that's the total, right? It's a total interior angle, but the question is asking about each. So in order to find that, and since we know it's regular, key word, we can simply divide by 9. Okay, so we simply divide this by 9. Now you want to learn a neat number trick? I can show you. Are we going to have a decimal for the answer? No. How do I know? Because we're dividing by 9, and these digits, 1, 2, 6, and 0, when I add them, I get 9. So it's divisible by 9. Yeah, neat trick. If you heard that, good for you. So anyway, I divide 1260 by 9. Let's see, that's 140. Okay? Yeah, I just did that in my head. So each interior angle of a regular nonagon is 140 degrees. That's how that works. But again, remember, each angle and each side has the same measure for definition of regular. So far we have used just these 2 first notes, right? So we have the sum of the interior measures, n minus 2 times 180, and we can find the measure of each by dividing by the number of sides. Okay? Okay. So what's next? Exterior angles? Yeah, buddy. So let's play around with exterior angles, I think. Oh, no, wait, we got some more. I remember this. Yep. So we got some more interior angle. Find angle measures. We have algebra now. So check this thing out. What's the measure of angle y in pentagon TODAY? Right? So in pentagon today, this is TODAY. What is the measure of angle y? Now, where in the world is angle y? It's here. Now, it'd be nice if we knew all the other degree measures, and guess what? We do. We have a degree measure here, 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 and here. Now, if this is a pentagon, right? If this is a pentagon, well, what's the total measure of the interior angles of a pentagon? And so the sum of a pentagon, right? Pentagon is 5, by the way. So it's going to be 5 minus 2 times 180, or 180 times 3, and that will give us 540 degrees. Okay, so the total sum is 540 degrees, right? But what do we know? We now know we have 120 degree here, 150 here, 110 here, 90 here. Well, whatever's left is going to be angle y. So we can do some subtraction, we can do some algebra, it all doesn't matter. So if you want to use the algebra way, right, this is what we would say. We would say the measure of angle 1, or actually the measure of angle t, plus the measure of angle O, plus the measure of angle D, plus the measure of angle A, plus the measure of angle y, equals 540, I should have said. Okay, so we have an algebra formula if you want to use it that way, and then just start plugging in numbers, right? So the measure of angle t, as we could see, is 110, right? And measure O is 90, and measure D is 120, and that's 150. And of course, we're looking for the measure of angle y, equals 540. Okay, so we just made an equation. Do we have to make an equation? No, we don't have to. If you know what you're doing, it's going to be a matter of subtracting all these things anyway, and I'll show you a shortcut in a second. So we can add up everything we have. 110 and 90 is 200, And that's, let's see, so 320 and 470. Okay, so we have 470 plus the measure of angle y equals 540. And then we just have our equation. We can subtract 470 from both sides. Right? We can just solve our equation. And so we know the measure of angle y is going to be 70 degrees. Okay, so we can find out that way. Now, here's a cheat. Cheat mode activated. Let me use the calculator for this. Now, we know the sum is 540, correct? So this is what we can do. We have 540. That's the total sum, right? But what's already there? We already know 150, so let's take that away. Minus 150, and we have minus 120, and then minus 90, and then minus 110. Whatever's left is going to be angle y, 70. Okay, so there's a cheat way of doing it. It's all algebra, so it doesn't matter. Either way, the measure of angle y is 70. The point is, let's apply algebraic thinking to what's happening. We have a pentagon. The total's 540. Let's take some stuff away. We'll find y. Okay? So same principle here. Pause and do this yourself. And then when you're done, unpause and watch me do it really quickly. So the measure of g in quadrilateral. Now, quadrilateral, the total amount of degree measures in a quadrilateral is 360. Okay, that's our total. And so all we have to do now is set up our formula, which I will do. I'm an algebra guy. Love me some algebra. So we have our formula, and now we just combine like terms. It's 205, so 258, right? Okay. Plus the measure of angle G equals 360. So I subtract 258 from both sides. Yeah, I'm doing this live, by the way. So we have 102. So the measure of angle G should be 102 degrees, right? So I can show it that way, or I can cheat. Okay, so I'm going to take my, I'll start with my 360 because that's my total. I'm going to subtract 120. I'm going to subtract 85. I'm going to subtract 53, 102. Okay, so everything checks. Yay. And that's how we can do that. Okay, so that's angle measures. Cool? Great. Finally, let's play around with exterior angles. So we have our note about exterior angles, right? The sum of the exterior angles of any polygon is 360 no matter how you look at it, right? So see if you can pause and figure this out. What's the measure of angle 1 in the regular octagon? Well, we have an octagon. That's 9 sides, right? It doesn't matter how many sides a polygon has. The exterior angles are always going to add up to 360. Exterior always add to 360. So to answer this question, yeah, it is that simple. All we have to do is divide 360 degrees by 9. That's all we have to do. An octagon has 9 sides. Exterior angles always add to 360. The measure of angle 1 is 40. Okay, so is the measure of angle 6, by the way. It doesn't matter, right? An octagon... Did you guys let me go this far without correcting me? Octagon has 8 sides. Mr. Katz, what's wrong with you? You get the point, though. 8 sides. Katz, what's wrong with you? 360 divided by 8. So if you were watching and stopped right there to email me, sorry, keep playing. Keep on playing the video. I caught the mistake. Anyway, what is that, 45? 45 degrees. There we go. Is that better? Holy cow. What was wrong with me? An octagon has 8 sides. No, there's a common mistake, I guess, or an uncommon one. I'm just that silly. Maybe I was looking down here. Yep. So I already answered this question then. What's the measure of an exterior angle of a regular nonagon? I'm not even going to edit this, folks. This is going live. I don't even care. So for my friends in Saudi Arabia, sorry about that if that was confusing. A nonagon has 9 sides. So it's the exterior angles, so 360 divided by 9. And now we know 40 degrees. Yay! Sorry about that mistake, y'all. I'm not even going to edit it. Let's move. So that's it. That is it for the unit, folks. That's it for the lesson, I mean. So that's it. Angle sums. It's pretty straightforward. I'm going to leave with a quick quiz. So check this out. Here's our quiz question. Hit pause, figure it out yourself, because I'm going to do it fast. All right, so hopefully you've unpaused by now. How many sides does a regular polygon have if each exterior angle is 24? Exterior angle. That means we divided something. We divided 360 by something and got 24. That's what that means. You got to know that. We divided 360 by something to get 24. So what was it, right? That's the question. So what was it that we divided? So how do we do that? Well, if you want to look at it algebraically, like I enjoy doing, we would have an equation that looks like this. So how do we do that? We can cross multiply. Bum, ba-dum, bum. So we know we have cross multiplication. 24 times x equals 360 times 1. We can do it that way. Or we could think about it and, do some guess and checks and all that stuff. But either way, we have x equals, let me see if I can do this in my head, 1 and 12. Nah, I can't figure it out, so I'm going to go calculator mode. I could have done it. I'm embarrassed. Sorry, guy. It's 15. So x equals 15. So that's the number of sides. We have 15 gone. So how many sides does a regular polygon have? 15 sides. Yay. Hopefully you figured that out. So anyway, that's our lesson for today on angle sum theorems. I hope you enjoyed. I hope you learned something, and I hope I didn't mess you up with that mistake. Hopefully you recovered. I'll see you in the next lesson, folks. Bye.